Reversing a string is easy, but what if you had to reverse only the vowels and keep everything else exactly where it is? In this video, I will show you a smart two-pointer trick that does it just in one pass. If you're new here, then I'm Radhika. This is my YouTube channel Datazard. Now without further ado, let's dive in. This is Leetcode problem number 345 called as reverse vowels of a string. Now the problem states that given a string S, reverse only all vowels in the string and return it. The vowels are A, E, I, O and U, and they can appear in both lower and upper cases more than once. So if we take this first example from here, we know that this is a vowel, this is a vowel, this is a vowel, and this is a vowel. Now we have to reverse the order of these vowels. So what we are going to do is this A will be switched with I. So these will be reversed and then these will be reversed. So the final answer would be A, C, E, C, R, E, because E and E, even if they get replaced, it's the same character. Then I and then M. So this would be our final answer. Let's try to understand how this can be done using two-pointer method. Now this is the same example that we have taken above. I have just put indexes for this string and I have color coded these vowels with yellow color. So if a character is not a vowel, then it is shown in green color, otherwise yellow color. So now if we have to define vowels, then our vowels would be equal to either A, E, I, O, U, or uppercase A, E, I, O and U. These are all the vowels that we can find in this string. Now here I'm going to initialize two pointers. My left pointer will be initialized at the first location in the string and my right pointer will be initialized at the end of the string. Now left pointer will move in forward direction and right pointer will move in the backward direction. Now we always have to ensure that our left is always less than right. These are both indexes. So left and right, they both store indexes and we need to ensure that this condition is followed all the time when we are updating left and right. Now what we will do is we will start with left and we will check the first condition that we will check is whether left is less than right. Yes, that is true. Then we are going to increase our left till we reach a vowel. So our first left position is the 0 position and it points to a vowel, so we don't have to update our left. Next, we are going to do the same for right. We are going to move right in the backward direction till we reach our vowel. So currently right points to a character which is not a vowel. It is not contained in this list. So we are going to move our right. So we move our right in the backward position. So right goes over here. Now our right points to a vowel. In this case, once both our left and right, they point to a vowel, we're going to switch these vowels. So I'm going to remove A and I and I'm going to replace them. So A will come over here and I will go over here. Now once this is done, we're going to update both our left and right to the next location. So the next location for left would be here and for right, the next location would be pointing over here. Now again, we're going to ensure that our left is less than right. Yes, that is true. And then we are going to check whether our left is pointing to a vowel. No, it is not. In this case, we are again going to move our left. Now we are again going to check whether left is less than right. Yes. And we are then again going to check whether our left is pointing to a vowel. Yes, that is true. In this case, we stop here. Then we again have to update our right till we reach a vowel. Now here our right at the moment points to a vowel. So in this case, we have vowels on both left and right. We're going to switch them. So to switch them, these are both same characters. So I'm just going to write E and E over here. We have switched them. And now again, we have to update our left and right. So we move our left to one position over here and right to one position over here. Always remember the direction in which left and right are going. Now again, we're going to check whether left is less than right. Yes, that is true. Now again, we check whether left points to a vowel? No, it doesn't. So in this case, we have to move our left to one position ahead. Now our left, does it point to a vowel? No, it doesn't. If it doesn't, then we have to move our left. But if we move our left to one position on the right, this condition would become false and we do not want that. So this is our stopping condition. As soon as our left is less than right, this condition becomes false. We have to stop, because then we know that we have switched all the vowels. So in this case, we stop over here, and if you look here, we have got the right output. So this becomes our output. So essentially what we are doing is, we are first initializing left at the start of the string and initializing right at the start of string. Then we are moving left in the forward direction and right in the backward direction till both point to a vowel. When this is done, ensure that our left is less than right, and if it is, then we just switch the left and right vowels. And we keep repeating this till this condition becomes false, and when it becomes false, this is our stopping condition. Let us understand how we can translate this in code. So now here, first we will define our vowels, and we can define this as a set, A, E, I, O, U, A, E, I, O, U. So we have covered both the uppercase as well as lowercase letters. Now I'm going to convert this string into a list. So I've converted this into a list by passing the string in the list function. Now I'm going to initialize left and right. Left will be initialized at 0 and right will be initialized as the last element in the list. So length of list -1, because the index of list starts at 0. That's why we have to do -1 here. Now while left is less than right, because I told you this is the stopping condition. Now we have to move our left pointer till it reaches a vowel, and we have to ensure that our left always remains less than right. So first I'm checking while left is less than right, and when s of list of left not in vowel, if that character which is at s list of left is not a vowel, then we have to keep moving our left. So left plus equal to 1, which is left is equal to left plus 1. Similarly, we have to do the same thing for right. So while left is less than right and not in vowels, till then we have to keep our moving our right, but right will have to move in the backward direction. So we have to do minus equal to 1. So right is equal to right minus 1. Now from these left and right, we would have arrived at our vowels location. So now we check if left is less than right. If this holds true, then we just have to reverse left and right. So s of left comma s of list of right equal to s underscore list of right and s underscore list of left. We have switched the positions in the list, and now we just do left is equal to left plus 1 and right is equal to right minus 1. And now at the end, we just have to join these strings together. So we do join s underscore list. And now when I just submit this, we can see that the solution gets accepted. Now let us do a dry run of this code to understand how the loop is running. Now I am using the same example as we did before, which is ice cream, and I'm going to dry run this code here. Now this is my s list. So I've converted this string into a list, and the reason why we have converted this string into a list, so that we can do this operation. We can replace left and right at their positions. Now let us start working through this code. So we have defined our vowels, and that includes all the uppercase and lowercase vowels. And this is our s list. Now we have to initialize our left and right pointers. So our left pointer starts at location 0 and our right pointer starts at location 7, which is the end of the string. Now we check while left is less than right. Yes, that is true. Left is 0, right is 7. While left is less than right, yes, that is true. We check whether s list of left not in vowels. S list of left Is this character I? Is this in vowels? Yes, it is. So this condition goes false, which means we are not going to increase our left. We go out of this while loop and come to this while loop. Now again we check whether our left is less than right. Yes, that is true. S list of right, which is this character M, is it in vowels? No, it is not, which means this condition is true. So we move our left, and left is moved in the backward direction. So here we are going to move our left over here, which is pointing at index number 6. Now again we check whether our left is less than right. Yes, this holds true. And S list of right not in vowels. S list of right, is it not in vowels? No, it is found in vowels. So we don't have to move our right anymore. If left is less than right, yes, that is true over here. Then S list of left and S list of right, we have to interchange them. So I'm just going to replace this and this. So A will come here and I will come over here. And now we have to move both our left as well as right. So I will move left to one position forward and I will move right to one position backward. Now once this is done, we are going to go back again in this while loop. Now we check while left is less than right. Yes, that is true. Left is less than right. And S list of left not in vowels. S list of left is this character C. Is it not in vowels? Yes, that is true, which means we have to increase our left. So we're just going to move this over here. Now again we check whether left is less than right. Yes, that is true. Is S list of left, which means this character E, is not in vowels? No, it is in vowels. So we don't have to increase our left, which means we have found that character at left position, which is a vowel. Now again we move to this while loop. So while left is less than right, yes, that is true. S list of right, which is character E, is not in vowels? No, it is false. It is in vowels. So we're just going to switch these two. So when we switch, because these are same characters, so it doesn't really make a difference, but still we have switched them over here. Now again, we increase both left and right. So left will point over here and right will point over here. Now again, we go back to this while loop. While left is less than right, yes, that is true. We check while left is less than right. Yes, that is true. And S list of left not in vowels. S list of left is C. Is it in vowels? No, it is not. If it is not, then we have to move our left one position ahead, which means our left will point at the same position as our right is pointing. Now again we check whether left is less than right. No, it is not. So we move out of this while loop. Then again we check here whether left is less than right. No, it is not. So we don't have to run this while loop. Then we check if left is less than right. Again, this is false. So we don't have to run these three if conditions. We go back to this while loop. We check whether left is less than right. No, it is not, which means we have completed this loop and our final answer is this. We're just concatenating this into a form of string. So answer is ACECREIM. So reversing only the vowels might sound tricky at first, but with two pointers approach, it's clean, fast and memory efficient. Instead of scanning the whole string multiple times or storing extra data like in the brute force method, we're just moving two pointers inward and swapping vowels as we go. If you're able to understand this approach, then hit that subscribe button. Thank you for watching. I'll see you in my next one.